Is it possible to turn coconut oil into a protective anti-corrosive coating on metal surfaces? Our project on the development of anti-corrosive coatings from vegetable oil has successfully accomplished this task, effective as a green alternative to its existing organic counterpart due to CocoShield's comparable waterborne and anti-corrosion properties in addition to its other physical properties. Anti-corrosion coatings are used in various end-user industries to protect metal components from structural failures caused by corrosion. The product is heavily consumed where metals are consumed in large quantities, including oil and gas, automotive, and infrastructure. The biggest challenge for end-user industries is to choose anti-corrosion coatings with a little impact on the environment. Thus, the demand for waterborne anti-corrosion coatings will rise significantly in the coming years. The global anti-corrosion coatings market size was $13.5 billion in 2020 and will showcase a growth rate of around 4.3% CAGR from 2021 to 2027. This project dealt with research, product development, and pre-commercialization of alternative coconut oil-based polyol and polyurethane waterborne anti-corrosive coating, namely CocoShield. This is a groundbreaking work that utilized coconut oil as a major component in the polyol blend for the synthesis of waterborne polyurethane coatings for corrosion protection. Coconut oil was successfully functionalized using a patent-pending process to produce the bio-based polyols blend. Globally, there is a tremendous pressure to move towards using renewable alternatives as raw materials for the manufacture of industrially important products. In the Philippines, the coconut industry constitutes a big part of our economy. This project answers to call to boost the Philippine coconut industry through research and development of high-value coconut products. CocoShield perform at par with existing available anti-corrosive and waterborne coating brands in terms of its major and important physical properties. These projects' journey started out with USAID's Science, Technology, Research and Innovation for Development, or the STRIDE program, as a research grant award to MSU IIT in 2016. The small laboratory facility pioneered the research on biomass-based polymeric material synthesis and testing in this institute. With the significant data gathered in a year's duration of the project, the Polyols and Polyurethanes project came about in 2017 as a part of the 3-year research program under the Department of Science and Technology, Philippine Council for Industry, Energy and Emerging Technology, Research and Development, or the DOST. This external grant had a significant impact on the research capability of MSU IIT, especially in the field of materials science and engineering, and has grown in its capacity to provide technical expertise and testing services related to polymeric materials. The facility has since shown excellence in sustainable polymer research and development owing to the Institute's strong administrative and research faculty support and hard-working research personnel. CocoShield is now in the pre-commercialization stage. With its simple chemical process and low-cost raw materials, this translates to relatively lower production and product costs, which are economically advantageous to startup companies or licensees willing to adopt this technology.